Hello, good morning, everyone. So, in the previous class, we started with OSPF, right? So, few questions I have given to you as a task. I think so. So, what were those? I asked why OSPF is called as a link state. Yes. What was the research behind that? Yes, online guys. Yeah, two tasks. OSPF is called link state. Second was why OSPF works on area concept. Yes, guys. Quick. Yes, online guys. No.
Routers exchange link state of information. That is the
Very
reason.
Good. So, if you talk about why OSPF is called a link state routing protocol is because OSPF calculates the best path based on the interface cost. We call metric as a cost in OSPF. Reference bandwidth, please mute your mics. Reference bandwidth divided by interface bandwidth. Based on the link cost, it will calculate the best path to reach to your destination. Good. So why OSPF works on the area concept is for faster convergence. Because it is very easy to calculate the best path within the area. So let us consider we have some 10 routers. R1, R2, R3, R4, R5, R6, we have R7, R8, we have R9. Let us consider we have R10 here. Now, let us consider R10 as the loop back /32. Now, in this topology, how much time it will take for R1 to calculate the best path for 10.10.10.10? It will take more time, correct? Compared to, let us consider we are dividing into areas. Area 0, and we are putting all these routers in area 1. So inside the area, it is very easy to calculate for that particular area, right? Instead of calculating for all the routers, it will calculate for those particular areas. So far, faster convergence. It will not divide the networks. Your information, even R1, R2, and R3 will have the full map of your network. That we'll learn how ABR works, how ASBR works. We'll talk about that. So why OSP works on the area concept? Because of our faster convergence. Clear? Yeah? Now. Now. So if you talk about R1, R2, and R3. So when you enable OSPF on all these three routers, they'll start exchanging LSAs. So LSA stands for link state advertisement. What does this LSA contain? Network topology means. So it consists of state of the link, means which type of link you are using, and the description of the link, means whether you are using gigabit or fast Ethernet or Ethernet interface. That's all what it is present in LSA. So these LSAs are stored in LSTB. There were around 13, 14, 16. So these LSAs are stored in LSTB. That we call it as link state database.
Mean this, we are saying it consists of state of the interface, right? State
Yes.
means is it up or down? What it is?
Not state. State means what is the interface bandwidth? What is the state means what is the bandwidth you are using on the link? And then the
And
description of the
description?
link, what type of link you are using, whether it is a gigabit, fast Ethernet or Ethernet type of link. Because your OSPF calculates the metric based on the interface bandwidth, right? That's what it advertises in each and every LSA.
Okay.
Yeah. So now we'll talk about OSPF message type. We call it as OSPF packet type. So how many OSPF packet types are there? Any idea? Five.
5.
So what are those?
Hello.
Okay.
Link state update, link state request, I think. Then
You got DVD,
LSU, LSR.
LSU, and we have
Acknowledge.
yes. So we have hello, database description. So we have link state request. We have link state update. And we have link state acknowledgement. Hello? What is the full form? Hello. No full form for it. Okay. So hello, it is used to establish and maintain neighborship. So what is the by default hello and hold on time? Yes. Yes, guys. For OSPF,
Depends upon the type of link.
depends on the type of the link.
And like it's a point-to-point broadcast or
Mm-hmm. What about others? Yes. 5 seconds. Okay. Then any other answer?
10 or 30 seconds
And not
and
30.
40 and 120 seconds.
It depends on the network type. Network type. Okay. Very good. So the answer is it depends on the network type. So hello and dead timers depends on the network type of the network. Good. So we talk about OSPF. OSPF has 5 network types. We have BMA, broadcast multi-access. We have NBMA, non-broadcast multi-access. We have point-to-point, point-to-multipoint broadcast, and point-to-multipoint non-broadcast. So it depends on the network type. So every network type has different hello and dead timer. We call it as dead here. There it is hello and hold. Here we call it as hello and dead time. Now, so DVD, it is used to exchange the routing information. No? So LSR, it is used to ask for any new updates inside the area. So LSU, this is sent in response for the LSR. So since OSPF is reliable, so for DBD, sorry, for DBR, it's DBD, LSR, and LSU, you will receive an acknowledgement back. So DBD, LSR, and LSU are reliable packets. These are reliable. This is about OSPF packet types. Yep. Since OSPF is reliable, so for DBD, LSR, and LSU, you'll receive an acknowledgement back. Done? Done?
One minute.
Okay. So let me know.
Yeah, done.
All right. Now, so now we'll discuss about OSPF neighbor states. So there are 8 OSPF neighbor states. We have down, we have attempt, we have init, we have two-way, we have extract, we have exchange, we have loading, and we have full. Loading. Yes. So this is the first state. This is the initial state. The routers. Downstream. Initially. So attempt state, this you rarely see in the network because this will come into the picture when we use NBMA networks like frame relay and all. Earlier we used to use. So now we are not using frame relay. So this state is rarely seen. This is used by NBMA networks. So in init state, one way, hello is sent. Both the routers will exchange hello. So very important point, DR-BDR. So DR-BDR election happens. We'll talk about DR-BDR, why we require DR-BDR. So DR-BDR election happens at two-way. Very important point. So in extract state, master and slave election. In exchange state, DVDs are exchanged. So in loading, LSR and LSU packets are exchanged. So we have full adjacency. So between two routers. Done? So, done, guys?
Yeah, done.
Okay. Now, so let us consider two routers. We have R1, we have R2. So initially, both are in the downstream. Now, when you go and enable OSPF here, so it will initialize sending a hello packet. One side, one way hello is sent. This we call it as init. Correct? Now, for a hello, do we get an acknowledgement back? Why? It's not a relevant packet. Good. So when both the sides send the hello packet, this state we call it as two-way. So important election happens here, that is DR BDR. So we'll talk about this DR BDR, what to remember DR, what to remember BDR, why we require first of all DR BDR election. So we'll talk about that. Direct. Okay. Direct what? Router? Direct router? Then it's designated router and backup designated router. So we'll talk about that. So then after two-way, let us consider R1 has 1.1.1.1/32. So after this, what happens? Master and slave. So why they elect master and slave? Any idea? Just election is going to happen. My question is why that election is needed? Mhm. So why we elect master and slave is who will start to exchange the routing information first. So whether R1 will start or whether R2 will start.
Main router for the head.
Head router is your DR. We'll talk about that. I'll come to that. Here is just who will start. What is it? First, who will start exchanging first the routing information. Yes.
So who will start to send the hello packet.
No, hello packet is done already. As soon as you enable OSPF, hello is done. Now at this instant, when X start state comes, who will start to exchange the routing information? This is the routing information, right? So even R1 can start, even R2 can start. Who will start? So based on the again highest router ID. If router ID is not there, highest interface IP. So after this, master and slave election. Why master and slave? Who will start? To exchange the routing information first. Master only, master, always master. Master, always master will start exchanging. In this case, R2 will start. Because highest router ID. If router ID is not there, then highest interface IP. Extract done. Now after that, exchange state. In exchange state, what happens? DBDs are exchanged.
But there is a concept called what is elected first? Is it a DR or BDR?
BDR first, then the DR. I'll come back. I have not come up to DR BDR lecture. We'll come. We'll talk
Okay,
about that.
okay.
First BDR, then the DR. I'll talk about that.
Sir, in the master slave election also, if everything is left default, then including if there is no router ID, the interfaces will be same. It's a
How interface will be same? Do you think interface IP will be same on both the routers?
interface IP. Okay.
IP, yes. Not the interfaces. Interface IP. Same like your election criteria for router ID. How you elect a router ID? First, it will check the highest interface loopback. Then it will check the highest interface IP address. Then exchange, DBDs are exchanged. After that, loading state, your LSR and LSU, any link state updates. And then it will go into the full adjacency. Okay. Now we'll see how to configure OSPF. Then we'll talk about DR later. So let us consider we have so all are in areas. So this is 192.168.12.0/24. This is 192.168.13.0/24. This is 192.168.23.0/24. This is dot one, dot two, dot two, dot three, dot one, and dot three. Now, how to enable OSP? So router OSP. So like how EIGRP works on the ASN concept, OSPF works on the process ID concept. You need to mention the process ID. Then you need to advertise the directly connected networks. Network who are directly connected to R1, that is 12.0 and 13.0. IP, you need to mention the wildcard mask and the area and the area ID. This is the syntax of enabling the OSPF. Wildcard mask is just the opposite of the subnet mask. Let us consider this is a subnet mask. Sorry. Opposite of this will be wildcard mask. This is your subnet. This is your wildcard mask. Then you need to mention area and the area ID. You need to advertise all the directly connected networks. Done. So now we'll see a basic lab on OSPF, how to configure. So what is the AD value of OSPF?
110.
What about for intra area? So everything is the same. What about intra area, inter area, and external?
Yeah, it is same, but only difference in the OIAE, that designation is different.
Very good. So AD value is the same. So we have only one AD. That is 110. So we just take 3 routers.
And one thing more, Chetan, I just need to confirm, it's out of box a question. My CCNA got expired, right? My CCNP route got
We'll
expired.
discuss it at the end of the class. I'll come back.
Yeah.
Okay. So once the class will finish, we'll discuss it. Area 0. So between R1 and R2, it will be 192.168.12.0/20. This is 23.0. It is 13.0. So when anybody is experiencing resound, echo, yes, online guys. What about others? No. Okay. No. Okay. Please check. Think. Okay, only one notification. Okay, thanks. Not one. Okay. Next. Interface. 0/0. IP address will be 192.168.12.1/24. Sure. So interface 0/1. So IP address will be 192.168.13.1/20. Question? Yes, 0/0. IP address will be 192.168.12.2/20. Interface is 0/1. The IP address will be 192.168.23.2/20. So go to R3. Interface is 0/0. IP address will be 192.168.13.3/24. Interface is 0/1. IP address will be 192.168.23.3/. So now go to R1 and enable OSPF. So router OSPF 1. Router ID, let us consider 1.1.1.1. Enter. So advertise all the directly connected networks. That is 192.168.12.0. And you need to mention the wildcard marks. Can you see? You need to mention the wildcard bits. That is 0.0.0.55 and area and the area ID. That is area 0. Enter. Then 13.0. 9168.13.0, 0.0.0.255 and areas. Enter. So router OSPF 1. ID will be 2.2.2.2. So network 92.168.12.0, 55 and area 0. Network 192.168.23.0, area 0. So go to R3. Right. Network 168.13.0, area 0. And you to address 23.0. So now what I configure? Check the IP addresses. Show IP interface brief. So on Z0/0 is 13.3 and Z0/1 23.3. Here, show run pipe section OSP. So I configured router OSPF 1, router ID, and I have advertised the directly connected networks. Clear? Now, first command to check. So now, in order to check which all are the interface are enabled under OSPF, the command is show IP OSPF interface brief. So this command will show you where all you have enabled OSPF 1. So you have enabled OSPF 1 Z0/1, Z0/0. It will show you the process ID, the area ID, and the IP address and the mask and the cost. So we'll talk about DR, BDR. Then it's about the neighbors. So this is a good command to troubleshoot if you're stuck in OSPF. It will show you everything on the process ID, area ID, common subnet, who is the DR, who is the BDR. No? On R2, show IP OSPF interface. So enabled on Z0/0 and Z0/1. Fine. So go to R3, show IP, OSPF interface, enable on Z0 and Z0. Now, so how to check the neighborship? Show IP, OSPF neighbor. Can you see? I have two full adjacencies with the 0.0.0.3 and 2.2.2.2. Full, the state is full. This is the dead time. So by default, it is working on the PMA network. Check show IP, OSPF interface. What is the by default network type? It is broadcast. What is the timers? Hello is 10 and that is 40. And the router ID assigned 1.1.1.1 interface address. So everything you can see with this command. Clear? So go to R2, check the neighborship. Show IP OSPF neighbor. I have two neighborships, 0.0.0.3 and 1.1.1 with both the neighbors. And even on the R3, we have two adjacencies. Two dot and 1.1.1. Done. Now, show IP route OSPF. So I have O route. O stands for intra area route. So if the designation is O, it is OSPF route, but intra area. Please mention here. If you see O, OSPF route, intra area means within the area. Intra area means within a single area. No? Clear? So everybody has any doubts? How to enable OSPF? How to check the neighborship? How to view which all are the interface inside the OSPF? And this is how you check routing table. Any doubts, guys? Still here, any doubts? No doubts? Okay. So we'll move on to the next concept, DR BDR. So DR stands for designated router. And BDR stands for backup designated router. Now the first question is why? Why we require DR BDR connection? Yes, anyone? Hope CCNA has been taught, right? Why? Why we require DR BDR?
avoiding loop, we have concept of known as DR, BDR.
Avoiding loops. Do you think DR/BDR will avoid the loops?
When we have same subnet interfaces,
Mhm.
router interfaces are there.
Okay.
All devices are connected on a switch. Then in that case, we need a DR/BDR. Because
That I
those
got to know.
routers
When you
are
are talking about broadcast multi-access, that I got to know. But my question is, why we require this first of all?
because that is used to send only those routers will send the advertisement to other routers. Others will not send.
Okay. So why we require DR/BDR is it is used to reduce the flooding of LSS. So this DR/BDR election happens in BMA network type. So we'll discuss about this network type. Don't worry about this. In BMA, that is broadcast multi-access and NBMA networks. So only in these two networks, you have DR/BDR election. So in point-to-point, point-to-multipoint broadcast and point-to-multipoint non-broadcast, we don't have DR/BDR election. This stands for broadcast multi-access. This stands for non-broadcast multi-access. So indirectly, we can say why we use DR/BDR is in order to reduce the number of full adjacencies in your network. But the proper answer is reduce the flooding of LSS. So now, done? Now, so let us consider we have a switch. So let us consider we have 4 routers. So let us consider the router ID as 1.1.1.1, 2.2.2.2, 3.3.3.3, and 4.4.4. Now, one of the routers should become the DR, and one of the routers should become the BDR. Now, if we talk about the election criteria, any idea about election criteria? How it elects a DR and a BDR? First, highest OSPF priority is preferred. So by default priority is 1 by default. This is OSPF priority, not STP. By default, OSPF priority on all the routers is 1. So first it will check the highest OSPF priority. If same, then it will check the router. Very good. So if same, then highest router ID. Now, what are the election criteria for router ID? This is for DR and BDR. For router ID, what are the election criteria? First, manually configured. Second, highest interface loopback. What is third? If loopback is not configured, then highest interface IP address. So let us consider on all the routers, we have the by default OSPF priority. Now, who will become the DR and who will become the BDR? First of all, tell me why we require a BDR? DR was enough, right? Backup, for backup sake. So if you talk about this BMA network, how many adjacencies is required? It is n into n minus 1 by 2. So that is 4 into 3 by 2. So total 6 full adjacencies if you don't create a DR and a BDR. So now, so if you talk about 10 routers, then we'll be having 45 adjacencies. As the routers goes on increasing, your full adjacencies will goes on increasing and more flooding of your LSAs inside the network. That's why they implemented the concept of DR and BDR. So now if we talk about the states, I hope this is clear. Done? It is written. Online guys, done?
Yes.
Okay. So if we talk about the states, so please mention it, very important for the interviews. So now neighbor states. Not those 8 neighbor states. So if we talk about DR and the BDR, so the neighbor state will be full adjacency, DR and DR other. Again we have full adjacency. So BDR and DR other. So I'll talk about this. Don't worry, just make a note. Full DR other and DR other, we have two-way adjacency. So if anybody asks in the interview, what is say? When you will see a two-way state, it is not stuck in. It is by default between DR other and DR other. You will see a two-way state. You don't have full adjacency between DR other and DR other. So what do you mean by DR other is, let us consider. Now in this network, R4 will become the DR. So always one more key point to remember, always BDR is selected first and then the DR. So we'll see in the lab. So BDR and then the DR. So these routers, we call it as DR others. Clear? So one more key point to remember. So always BDR is selected first. And then the DR. Done? Okay, now we'll see a lab. Let's consider a switch. Let's consider 4 routers. Okay. So let us consider the network 192.168.1.0/20. So R2 will be .2. .3. Which one you want to add? Why you want a PC? Do you think PC will elect a DR BDR election? What loopbacks? Uh-huh. Huh. You want to use a hub? So we'll discuss after the class. Discuss after that. I'll come back to that point. So area 0. So let us consider the router ID. R2 will be 2.2.2.2. So I'll be manually configuring these router IDs. R2, R3, R4, LON, R5. So let's configure on the notepad. So basic IP address. So on R2, interface 0 0. So IP address will be 192.168.1.2/24. No shit. So router OSPF 1. So router ID will be 2.2.2.2 and network 192.168.1.0 wildcard mask area 0. So on R3, Z0 bar 0 will be 192.168.1.3. Router ID will be 3.3.3. And enable OSPF on the 1.0 network. So on R4. So Z0 bar 0 will be 192.168.1.4. Router OSPF 1. Router ID will be 4.4.4. I need to enable OSPF on the directly connected network. That is 192.168.1.0, wildcard mask, and area 0. So on R5. .5. No, enable OSPF on 1.0. Now we copy paste. R2. R3. R4. And R4. No, wait for the adjacency. Short OSPF neighbor. Two-way. Show IP. Now you can see the states here. So 2.2.2.2 is elected as the DR other. 3.3.3.3 is also a DR other. Who is the BDR? 4.4.4.4 is elected as the BDR. Now you go and check on R4. We'll show you DR others and the DR. Show IP OSPF neighbor. So can you see here who is the DR? 5.5.5.5. Why? Because of the highest router ID. Because the by default priority is 1. So now, so before moving on, let me debug IP OSPF adjacency. Let me clear it. Clear IP OSPF process. See the DR BDR election. First, the BDR will be elected. Can you see here? First, the BDR, and then it will elect the DR. So it is fast guy. So every 10 seconds, so it will be exchanged. Can you see? First it will elect the BDR and then the DR. First BDR and then the DR. I hope this part is clear. And the adjacency part is also clear. So with DR BDR, we have full adjacency. Only between DR other and DR other, we have two-way adjacency. If you go and check on R2, just check here. Show IP OSPF neighbor. Can you see two-way here? Two with 4. I think 1 second election. I clear the process rate. Yep, 1 second. The routers. Then it will elect the process. That is the point. Just wait. Copy OSPF neighbor. Wait. Not so. With DR other, the state is 2, not with DR other and the BDR. Wait, election is happening. Few moments. Done. So why debug? Start. Now check. So who is the DR? 5.5.5 is the DR. 3.3.3 is the DR other, and 2.2.2.2 is the DR other, and we have full adjacency. So now if you go and check on R2, show IP OSPF neighbor. Only with DR other and DR other, can you see we have two-way adjacency. Who is the DR other here? So he is the DR other, and he is the DR other. He is the DR, and he is the BDR. I hope this part is clear. Yes, yes. Any doubts still here? You can ask me. I'm done for the day. So tomorrow again we'll continue with the DR BDR. So we have a few more points to tell on DR BDR. I'll just save this. Any doubts? Anybody has any doubts still here? They can ask me. I'm done for the day. No doubts? No, sir. Okay. So everybody's clear? Okay, guys. So today we'll end up. We'll continue tomorrow. Bye, guys. Have a nice day.